let's talk about representing sets. So I'm going to say a set of X, data definition, a set of X is a list of X's with no duplicates. So empty, for example, is always a set of X because there are no duplicates in empty. Let's write, I'm going to write a function called myMember, which takes an X and a set of X's, takes a sardine and a set of sardines, and gives you back a Boolean, depending on whether the X you give it is in the list. Okay, so we've already done this a few times, but let's do it again. Define myMember X locks. Okay. So of the functions on page 302, which of those functions, if I wanted to use one of those abstraction functions, which one might work here?
Or map.
Right? Or map, right? I want to say, is there an element in locks which is equal to X? Okay, so I'll define myMember as local, define is X, define equal XY as equal XY. Okay, so this is, let's see, actually I don't want to do that. Let's call this other X. Okay, so this guy is a function that will take some other X and see if it is equal to the X that you're looking for. So now I can just say or map equal X locks. Now, here we've given this a name, which it's okay because we're inside a local, but in fact, one of the nifty things is that we don't have to give a function a name. We can use this thing called lambda, which builds a function without giving it a name. So this is exactly the same function. It's exactly the same thing, except that instead of creating this function and giving it a name, equal X, I've just said, yeah, for each other X, ask whether it's equal to X. Same function. Okay, and I passed that function directly to ORMAP. I didn't bother giving it a name first. And that works just fine. Okay. Let's try subset, What's the definition of subset? How do we know when set 1 is a subset of set 2? Okay, so you're asking whether every element of set 1 is an element of set 2. Okay, good. Now, what abstraction of the ones we've just talked about, what abstraction does that sound like?
Each element of set 1 and see compared with all the elements in set 2.
Let's see. You're asking whether you said set 1 is a subset of set 2 if every element of set 1 is an element of set 2. You're asking a question about the elements of set 1, right? What kind of question are you asking about the elements of set 1? Your choices are map, fold R, filter, and map, and or map. So the first question is, what kind of a value do you expect to get out? Right? What's going to be the contract for Boolean? Okay. Which of our abstraction functions, of the functions on page 302 that we showed just a minute ago, which of those produce Booleans? Does a map produce a Boolean? What does map produce? Somebody it produces a list of things. Okay, which functions produce Booleans? Let's go back and look. Okay, yeah, well, let's see. Fold R could produce a Boolean if you asked it nicely. Build list is never going to produce a Boolean. Filter is never going to produce a Boolean. Ah, here we go. And map and or map produce Booleans. Okay. So for subset, right, we ask the question, is every element of set 1 an element of set 2? Does that sound like an and map question or an or map question? An and map question. Excellent. And what is the question that we are asking of each element in set 1? Take a random element from set 1. What question are you asking about it? Say again? Is it what? Is in what? Present, yes. Is it present where? In set 2. Okay, good. So the question I want to ask is in set 2 of X. Okay. Right, that's the question I want to ask. And now what I want to say is and map is in set 2. And I want to ask that question about every element of set 1. Nitesh. Where's Nitesh? Nitesh. So now all we have to do is define is in set 2. How are we going to define is in set 2?
We can use an or map to check if X is in set 2.
Have you been awake for the last 10 minutes?
Yes.
Is the solution on the board?
My member.
Say again?
My member.
My member! Yeah, we just did it! You don't have to think about it anymore. Right? That's the whole point of this game. Right? You do it once, and then you use it. And you don't have to think about it. Right? It's all about making your life simple. All right, say my member X set 2. There. Okay. Oops. That was supposed to be there. Okay, good. Great. Now, how am I going to define set equal, huh? Aha, very good, right? So I already have all the tools that I need. I just say and subset set 1, set 2. Subset set 2, set 1. And we are good to go. Demetrius.
Are we allowed to use my-length half without defining using set 2 half? Directly to the alpha.
Well, right. I'm, right, I can just, I could, of course, just use a lambda there.